Hey everyone, Emily here for D News. Frogs' tongues are sticky and extremely fast. They can capture insects 5 times faster than you can blink and grab mice and birds that weigh up to 1.4 times the frog itself. For a long time, scientists didn't have a full understanding of how that was possible, but a new study published in the Journal of the Royal Society Interface uncovered the true nature of the frog tongue. The researchers discovered that frogs are able to catch their prey because their tongue is incredibly soft and is coupled with saliva that changes its viscosity, or its thickness, depending on the situation. Here's how it works. When a frog goes to capture its prey, it slaps its tongue at the victim. Because of its squishy, soft nature, the tongue curls around the prey and acts like a shock absorber, taking in the energy of the impact and preventing the food from bouncing away. A frog's tongue is about 10 times softer than a human's, which allows it to be 10 times as stretchy, spreading over a large area of its victim. This larger contact area gives it better adhesion, so it doesn't drop its food. Once the tongue makes contact with a fly, mouse, or bird, then the saliva goes to work. The saliva is a non-Newtonian fluid, which is a fancy way of saying that it's a fluid that doesn't follow normal fluid rules. Unlike regular liquids, like water, a non-Newtonian fluid can change its thickness under pressure. A frog's saliva, for example, gets thinner when the tongue smacks its food. This allows the spit to spread over the prey. As the tongue retracts, the saliva becomes thicker and effectively holds on to the victim. Once the food enters the mouth, the frog sinks its eyeballs into its head to exert pressure on the tongue and force the food down. This also thins the saliva again, causing the prey to slide off the tongue and go down the frog's throat. Scientists have long studied the stickiness of amphibian and reptile tongues to try to learn more about adhesives. But so far, we have yet to develop a synthetic material that can match the speed and versatility of a frog's tongue. Now that we know more about how a frog captures its prey, this could inspire the design of reversible adhesives that could work at high speeds. One example could be a manufacturing plant, where you had to pick up delicate components quickly from a conveyor belt. Another researcher suggested that it could lead to the possibility of drones fitted with artificial frog tongues that could grab objects in flight. So if you're looking to grab things on the go fast, just consult a frog. If you want to know more about frogs, check out this video on weird frog discoveries here. What about you? Is this the most you've ever thought about frog tongues? Let us know in the comments, subscribe, and come back here for more D News every day.